Welcome back, everyone. Ready to dive into something really cool today? We're talking about ultra-faint dwarf galaxies.
Yeah, these things are fascinating.
Some of like the shy guys of the universe, right? The faintest galaxies we know of.
Absolutely.
Yeah.
Just a handful of stars compared to the billions and billions in, well, a normal galaxy.
Exactly. Our Milky Way has, what, hundreds of billions of stars? These guys have maybe a few hundred or 1,000 tops.
It makes you wonder how they even hang together.
Right, and finding them is hard enough, but trying to figure out how they form, how they evolve, that's a whole other challenge.
Especially since most of the ones we've found so far are pretty close to the Milky Way.
Yeah, and that's a problem, right? Because the Milky Way's gravity kind of messes with our observations, makes things tricky.
Like trying to study a whisper at a rock concert.
Perfect analogy. But there's good news.
Oh, yes, some very exciting news.
Astronomers recently found a group of these dwarf galaxies, but way out in a quieter part of the universe.
A much quieter neighborhood, you could say.
Exactly. 3 of them, hanging out near this spiral galaxy, NGC 300, and they're far enough away from any big galaxy's influence.
So we can finally get a clearer picture of how these ultra-faints tick without all that gravitational interference.
It's a rare find. I bet astronomers are pretty stoked.
Oh, absolutely. Especially since this wasn't some big automated sky survey that found them.
You're saying this was a human discovery?
Old school, boots-on-the-ground astronomy. Well, eyes on the data anyway.
So someone was actually looking through the images.
Astronomer named David Sand. He was looking at data from the DESI Legacy Imaging Surveys. Huge amount of sky images.
And he spotted these little guys that everyone else had missed.
Yep, he found these faint blips, these tiny smudges of light that no one had noticed before, hiding in plain sight.
Wow, that's incredible. Talk about a needle in a haystack.
And what's even cooler is what these galaxies, they're calling them the sculptor galaxies, what they're telling us.
Okay, tell me more. What's so special about these sculptor galaxies? You mentioned they're like, what was it, cosmic ghost towns?
Yeah. Exactly. Just a handful of really, really old stars, ancient stars, and no gas to speak of.
No gas. But isn't gas kind of important for galaxies?
It's essential. Gas is the fuel for new stars. So if there's no gas, there's no new star formation.
So that's why they're called ghost towns. They're basically dead in a way.
In terms of star formation, yeah, they're pretty much dead. Been that way for billions of years, probably.
So the big question is why? Why did they stop making stars?
That's the million-dollar question, or maybe the billion-dollar question, given the scales we're talking about here.
All right, so let's get into those theories. The ones you mentioned about why star formation just switched off in these galaxies.
Right, there are a couple of main contenders, and these isolated sculptor galaxies. They're the perfect test subjects, because they haven't been messed with by any nearby giant galaxies.
Right, they're like a controlled experiment in a way.
Exactly. The first theory has to do with what's called the Epoch of Reionization.
Okay, Epoch of Reionization, that sounds pretty intense.
It was. This was a period not too long after the Big Bang, when the universe was basically flooded with these super energetic ultraviolet photons.
Ultraviolet photons, those are the things that give us sunburns, right?
Same idea, but on a much, much grander scale.
So are you saying these photons, they could have just blasted away all the gas in these small galaxies?
That's the idea. Like a cosmic wind, sweeping through, stripping them bare, basically sterilizing them. No more star formation possible.
Wow, so it's like the universe itself just shut down their star-making factories.
It's a good way to think about it.
Now, what about that second theory? You mentioned something about internal feedback.
Right, this one focuses on the stars themselves, the early stars in these galaxies. See, back then, stars were much bigger and hotter than the ones we see today.
And when they died, they went out with a bang, right? Supernovae.
Exactly. But these weren't just any supernovae. We're talking explosions so powerful they could fling gas out of an entire galaxy.
Seriously, a single star exploding could do that.
Oh yeah, these supernovae were incredible. Imagine an explosion pushing gas out at millions of kilometers per hour.
That's mind-blowing. So these spectacular supernovae, they could have been the sculptor galaxy's undoing.
It's possible. Early generations of stars, going supernova, they might have blasted away all the remaining gas, essentially choking off any further star formation.
So it's like the galaxy's own success sabotaged its future. Kind of tragic in a way.
Yeah, but also pretty amazing when you think about it, the power of these events.
So which theory is right? Or is it still a mystery?
That's the thing. That's why finding more of these isolated galaxies is so important.
Because they can help us figure out which theory is more likely.
Exactly. We need to know how many of them were affected by this early cosmic wind, versus how many might have been victims of their own internal fireworks.
Like gathering evidence, piecing together the clues.
It's like cosmic archaeology, trying to understand the history of the universe by studying these ancient remnants.
That's a great way to put it. But finding these faint galaxies, it can't be easy, even with our best telescopes.
It's definitely a challenge, which is why astronomers are turning to some pretty cool technology for help.
Oh, are you talking about artificial intelligence? I've heard they're using AI to find new planets and things.
That's right. They're using AI, specifically neural networks, to help sift through all that data from sky surveys, like the one David Sand used.
So they're training these AI systems to spot the telltale signs of ultra-faint dwarf galaxies.
Exactly.
Yeah.
It's like having a superpowered assistant astronomer scanning the skies for these hidden gems 24/7.
That's amazing. So the more galaxies we find, the better we can understand these enigmatic objects, right?
Exactly. And their role in the grand story of the universe, how they formed, how they evolved, what they can tell us about the conditions in the early universe.
It's incredible to think that these tiny, faint galaxies could hold such crucial clues to the universe's evolution.
They might be small and faint, but they're packed with information, just waiting to be unlocked.
Well, I'm definitely hooked. This is fascinating stuff, and I can't wait to dive deeper into these sculptor galaxies and what they can teach us.
Yeah, me too. There's so much more to explore, and I'm excited to share it all with you.
It's amazing to think that these sculptor galaxies, they're billions of years old, haven't formed stars in ages, but they're still holding together. You'd think they'd just kind of dissolve over time, wouldn't you?
You would, right? I mean, they're so small, so faint. It's like, how are they even still there?
Right.
But that's another clue that something else is going on, something we can't see.
You're talking about dark matter, right? That mysterious stuff that astronomers think makes up most of the universe, but we've never actually seen directly.
Dark matter, we know it's out there because of its gravity, how it pulls on everything else. And it seems to be really concentrated in these halos around galaxies, like invisible scaffolding holding them together.
So you're saying these sculptor galaxies might be wrapped in these massive dark matter halos, and that's what's keeping them from just falling apart, even though they're not making new stars anymore?
That's one of the leading theories, yeah. And it's why these galaxies are so interesting to study. They're like these little natural experiments showing us the power of dark matter on a smaller scale.
It's kind of mind-blowing to think that these tiny, faint galaxies could be telling us something about one of the biggest mysteries in cosmology.
And it's not just about their structure. Remember how we talked about those two theories for why their star formation stopped the Epoch of Reionization, where those high-energy photons blasted away their gas, and then the internal feedback from supernovae?
Right, those two big possible culprits.
Well, studying these isolated galaxies can help us figure out which theory is more like. It's like having a control group, right? If we find a lot of these isolated galaxies and they're all gas-free, it points towards that early cosmic wind being the main factor. But if some of them have managed to hold onto their gas for longer, maybe internal feedback plays a bigger role.
So each one of these little galaxies is a piece of the puzzle, helping us understand what happened billions of years ago.
And remember, the sculptor galaxies are near, but not too near. The spiral galaxy NGC 300 that gives astronomers another way to compare and contrast, right? Because NGC 300, it's still actively forming stars. It's got plenty of gas. It's a very different picture. So by studying them together, we can see how environment might have played a role in the sculptor galaxies becoming these stellar ghost towns.
So are there any other clues about how these galaxies have changed over time? We've talked about the lack of gas, the potential influence of dark matter, but is there anything else that tells us about their evolution?
Cool. One intriguing detail is the age of the stars themselves. The stars in the sculptor galaxies are incredibly old, which suggests that star formation happened in a very short burst early in the universe's history.
So it's like a brief burst of activity and then everything just stopped.
Exactly. And that adds another layer to the mystery. What caused this sudden burst of star formation, and why did it shut down so abruptly? These are questions that astronomers are still trying to answer.
It's like trying to piece together a cosmic crime scene billions of years after the fact.
That's a great analogy. And these sculptor galaxies are giving us some tantalizing clues, but the full story is still unfolding.
It seems like with every answer we uncover about these galaxies, we're met with even more intriguing questions.
That's the beauty of scientific exploration. Every discovery opens up new avenues of inquiry. And as we continue to study these faint galaxies, who knows what other secrets they might reveal about the universe and our place within it.
Makes you wonder, doesn't it? These ancient galaxies barely hanging on, and yet they could hold the key to understanding some of the biggest questions in astronomy, like what is dark matter, really? Or how did the universe evolve early on?
It is incredible, yeah. These ultra-faint dwarf galaxies, they're like cosmic fossils,
Yeah.
giving us these little glimpses into a time when the universe was a very different place.
You mentioned earlier that David Sand, he found these galaxies by actually looking through images himself. I mean, I'm picturing astronomers hunched over their computers staring at these massive data sets. Is that how most of these discoveries actually happen?
Well, it used to be. But things are changing rapidly. David's discovery, it was a testament to his, dedication and his keen eye. But imagine trying to do that for the entire sky. It would take lifetimes.
That's where those AI assistants come in, right? The ones you mentioned before.
Exactly. Astronomers are now training neural networks to analyze these huge data sets from telescopes, like the DESI Legacy Imaging Surveys, which is what David used. These networks can sift through, terabytes of data looking for the telltale signs of ultra-faint dwarf galaxies.
So it's like having a team of tireless, super efficient astronomers working around the clock to find these hidden galaxies.
That's a great way to put it. And the exciting thing is, these AI systems are getting better all the time. They're learning to recognize patterns and features that even experienced astronomers might miss.
So what does the future hold for research into these galaxies? What are some of the big questions that astronomers are hoping to answer next?
Well, one of the big ones is figuring out how these galaxies fit into the larger picture of galaxy evolution. We know that galaxies grow through mergers and interactions. But did these ultra-faint dwarfs, did they ever interact with other galaxies? Or have they always been loners?
It's like figuring out their family history on a cosmic scale.
Exactly. And understanding their history can tell us a lot about the conditions in the early universe and how those conditions led to the diversity of galaxies we see today.
So it seems like we've only just scratched the surface of what these tiny, faint galaxies can teach us.
Absolutely. They're like hidden treasures waiting to be discovered. And with the power of new technology and the tireless curiosity of astronomers, we're bound to uncover even more amazing insights in the years to come.
Well, what a journey this has been. We've explored the universe's hidden corners, delved into the mysteries of star formation, and even pondered the unseen influence of dark matter.
It's been a true deep dive into the fascinating world of ultra-faint dwarf galaxies. And who would have thought that these seemingly insignificant objects could hold such profound clues to the universe's past, present, and future?
And remember, folks, this is just the beginning. With every new discovery, we get closer to understanding the grand story of the cosmos and our place within it. Keep looking up and keep exploring.